In the last chapter, we talked about whole numbers, and in this chapter, we're going to expand the system of numbers that we discuss into a new set of numbers called integers, and integers contain negative numbers. Now, the notion of a negative number is not really uncommon to us. We can think of several situations that would lead to a negative value. In Ohio during the wintertime, for example, if the temperature is 10 degrees outside and then at night it falls 15 degrees, then what is the new temperature? We say that it's 5 degrees below zero, or it's -5. In a similar way, if we talk about altitude as being positive and airplanes fly at thousands of feet, how do we describe the altitude of a submarine? You see, because a submarine is below sea level, so its altitude could be thought of as being negative. At any rate, there are a number of other examples as well. The number line helps us to describe positive and negative numbers, the set of integers. And here are the integers on a number line. Notice the positive numbers lie to the right of 0, negative numbers lie to the left of 0 on the number line. 0 itself, by the way, is neither positive nor negative, but numbers that lie on either side do indeed have a sign. 0 is called the origin of our number line when we're talking about integers and other sets of numbers that we'll encounter later. The integers, if we list them, we would list them this way. The integers contain all of the whole numbers that we talked about before, but also the negatives of these whole numbers, you see, on the other side. And notice the ... over here and the ... over here, meaning and so on in the pattern that we've established. So we have the infinite number of numbers, infinite number of positive numbers over here, infinite number of negative numbers on this side. Let's talk about the order relationship between numbers that are both positive and negative. Now, we talked about order relationships before, and order relationships are described using inequality symbols. Remember the less than and greater than symbols that we talked about before. Have you forgotten which way the little inequality symbol points for less than and for greater than? Well, it's okay if you do. Remember, we talked about the idea that the little inequality symbol always seems to point toward the smaller number, and so we can tell which way it points by doing this. Just write down a couple of numbers that you know the relative size of, like 1 and 4. 1 and 4. Make the little inequality symbol point toward the smaller one and read it as you understand it. We understand that 1 is less than 4. Oh, that means less than. If we had written the numbers the other way around and make the arrow point toward the smaller one, read it as we understand it, and we understand that 4 is greater than 1. Oh, this means greater than. All right, so less than, greater than. Let's put these pairs of numbers in order, or write the order relationship properly. Now for 2 and 5, again, it's the idea that the little arrowhead points toward the smaller one, and we can just take that kind of approach right here if we want to, but a really good way of thinking about all of these pairs is to just decide which one lies to the left or right of the other on the number line. Numbers that lie to the left are less than. Numbers that are to the left are less than numbers that are to the right. Numbers that are to the right are greater than numbers that are to the left. So if we're thinking about the number line, 2 is to the left of 5, so 2 is less than 5. -4 is to the left of 1, so -4 is less than 1. -15 is farther to the left on the number line than 6, so less than goes here. Generally speaking, too, when you see both negative and positive numbers in an order relationship, it's always true that the negative number is smaller than the positive number. And the only tricky part, if there is one, is when both of the numbers that are listed here happen to be negative. And then you really have to actively think, which one lies farther to the left? Well, -8 is farther to the left than -3, so -8 is less than -3. For 7 and 3, we've had this kind of thing before. 7 is greater than 3. 2 and -5. Now, any positive number lies to the right of any negative number, so any positive number is going to be greater than any negative number. And 4 then is also greater than -20. Here we have two negative numbers. Now let's see. -3 lies to the right of -15. -15 is farther to the left, so it's smaller. And therefore -3 is bigger, the larger of the two numbers. So -3 is greater than -15. Let's put these numbers in order, smallest to largest. And again, think about it on the number line. On the number line, negative numbers are to the left, positive numbers are to the right. The smallest number would be the one farthest to the left. And the one farthest to the left would be -5. So -5 would be the smallest of these. And the only other negative number is -2. And then would come 0. See, right in the middle of the positive numbers and the negative numbers. And then let's see, between what's next after 0? Well, it would be the 1, and then the 4 would be the largest of these. Now, by the way, the positive numbers can be indicated or emphasized using the little plus sign. We could say that this is +4. We could say that this is +1. Generally, for positive numbers, we don't write the plus sign unless we want to emphasize some kind of point somewhere. But just understand that it's understood to be there when we're talking about positive numbers. But for negative numbers, we always have to write the negative. Another idea associated with the number line is the notion of opposites. The opposites are numbers that are the same distance from 0, but on opposite sides of 0 on the number line. So if we're talking about 3, then the opposite of 3 would be -3, because those two numbers are both 3 units from 0 on the number line, but they're on opposite sides of 0. So they are opposites of one another. 7 and -7, -2 and 2, -4 and 4. These are all opposites of one another. Suppose we want to write the opposite of these numbers. Well, let's see, the opposite of 5 would be, you see, all we're doing is it's kind of like if there's no minus sign, we put one, and if there is a minus sign, we take it away. I mean, we can kind of think of it like that, but it's a pretty good idea to understand conceptually that it's the same distance from 0 on the number line, but on the opposite side. Okay, the opposite of 5 is -5. The opposite of 8 is -8. The opposite of -7 is 7. The opposite of -10 is 10. Now, let me show you a little bit of, let's talk terminology here just a little bit. We say that the opposite of 3 is -3. We describe this number as the opposite of 3, and yet we also describe it as -3. It turns out that that idea of thinking about that little minus sign as being -3 and thinking of it as being the opposite of 3 mean precisely the same thing. So that little minus sign can be thought of as negative or opposite, and that allows us then to evaluate certain situations, well, like this. What does this mean? Well, it means the negative of 5, or it means the opposite of 5, the opposite of +5, just putting it in there for emphasis now. So this means the opposite of, or the negative of 5. Well, that's just -5 or -5, we say. Now, what's this? This is the important point here. It's the idea that this is the opposite of -5. What's being described here for this number? How can we simplify this a little bit? Well, the opposite of -5 is 5. So it's kind of handy then to read this as the opposite of, you see, instead of the negative of -5, it's the opposite of -5 to give this. All right. So our plus sign and our minus sign then begin to take on different meanings, but those meanings are consistent with one another. A plus sign means positive for a positive number, but it also means add in some context. And this symbol means negative, it means opposite, it means subtract sometimes, you see, and all of these are consistent with one another, these various meanings. Let's talk about another idea that also has to do with the number line, and it's absolute value. Absolute value. I can kind of explain it better with an example than I can a definition. The absolute value of 5 is 5. The absolute value of -5 is also 5. No big deal. It's kind of like the value is always positive when we talk about absolute value. And a lot of times absolute value is described as distance from 0 on the number line. How far from 0 are we in units on the number line? Well, the distance from 0 to 5 is 5 units. The distance from 0 to -5 is also 5 units. You see, distance is considered to always be positive. Now, that's not true in every single mathematical context, I'll grant you. But if we're talking about distances along a highway, if I'm in Orlando, and I am, and I'm thinking about the distance to Atlanta, you see, Atlanta is north of Orlando. And then I think about the distance to Miami. Miami is south of Orlando. Now, those two cities are in opposite directions, but I still describe the distance to them in terms of miles, some positive number of miles, even though they're in opposite directions. So we're talking distance here from 0 on the number line, and the value is always positive. The absolute value of negative 7, 7. Now, what does this mean? This means the opposite of the absolute value of 4. Now, a lot of times in problems like this, when they get a little convoluted or there's more activity in them than we want to think through all at one time, the thing to do is to simplify in parts. Here, let's not worry about this. Let's just worry about that. You see, let's just slide over with this. Let's just bring that minus sign over and decide what this means. Well, the absolute value of 4 is 4, so let's write that over here. Oh, this means negative 4, you see, or the opposite of 4, whatever. But this is the simplification of that. And in a similar way, we can work this one. We can think, well, gee, I know what this means, so let's just bring that over. You see, I know what that means, that's 4. So this is, you see that. Now, if x is negative 6, let's evaluate the absolute value of negative x. If we're evaluating, finding the value of, it means we replace x with the value we are given for it. So I have, let's see, absolute value. I'll bring over this minus sign. Now what's x? Oh, x is negative 6. So I have minus negative 6. Now in a situation like this, where we have a couple of signs that follow one another, whether they're both plus, whether one's plus, one's minus, doesn't make any difference, both minus in this case, you want to separate them with a parenthesis somehow. You see, like this. Now this says the opposite of negative 6. Well, that's 6, and we're still inside this absolute value symbol, you see. So we're just simplifying just one little thing at a time. The absolute value of 6, of course, is 6. Let's talk about a couple of situations involving integers. One of them involves the sport of golf. And you may know that golf is scored according to the number of shots or strokes that are required to complete a round. And the average or the par number of strokes to complete a round is 72. Now, very few amateur golfers achieve that goal of scoring as low as a 72, but professional golfers do it all the time. And because of that, professional golf scores are often based upon par. That is, they are some score either above or below par. So if a professional golfer shoots let's say a 74, a professional golfer has a relatively bad round and shoots a 74, well, that's 2 shots over par, so that golfer may be considered to have shot a +2. You see, so many based upon par. Now, and scores and tournaments are based on par in that way as well. So a negative value would be a certain number of strokes below par. Consider that these are the scores of certain golfers, and let's say this is the results of a tournament, and I'd like to know who won this tournament. Well, this person, Gibbs, shot +3, that's 3 shots above par. Moore shot -5, well, that's 5 shots below par. Jones, 8 shots below par. Higgins, 1 shot below par. The best score is the most number of strokes below par, you see. So that would be Jones won the tournament, and out of these 4 golfers, Gibbs did the worst of these 4. Here's another situation. It involves rocket blast-off time. Which is closer to blast-off, -12 minutes or -17 minutes and counting? You see, a lot of times when you watch the blast-off of a space shuttle or something like that, you hear the announcer say T minus such and so. T minus, what does that mean? Well, it's time minus, the blast-off time minus a certain number. So there's a negative value associated with the time prior to blast-off. So a T minus 12 minutes or a T minus 17 minutes, these are times prior to blast-off. 17 minutes before blast-off would be a larger amount of time before blast-off than 12 minutes before blast-off would be. This is the time that is closer to blast-off, -12 minutes.